But this video is for the exam questions for quiz 5. You don't need to do any of the rates of reaction stuff because we haven't done that yet. So you're starting on page 6 and you're doing exam questions on atomic structure and the periodic table. The first question here is on calculating relative atomic mass. It's a really simple calculation, okay? All you need to do is the percentage times the mass number. So I've got 7.59. The mass of lithium is 6, all right? It's not minus 6, that's just a dash. Then I do percentage, 92.41, times the mass number again, which this time is 7. I add those two values together, and because I'm dealing with percentage, I divide by 100. Common mistake is students will put a multiplication sign between the two brackets, okay? To check that you're definitely right, use your periodic table. You're trying to work out the relative atomic mass of lithium, okay? On your periodic table, that value is 7. Your answer should be close to 7. It won't be exactly 7, but it should be close to 7. And if it's not, then you have made a mistake. Okay, so it says give your answers to 2 decimal places, but it should be very close to 7, maybe 6.99 or 6.90, something along that lines. If it's not close to 7, you've made a mistake. And the most common mistake is to put a multiplication between the brackets, not a plus. The next question is the same, but this time, instead of giving you the percentages, you have to use the graph to work them out. So at the bottom, they give you the mass numbers, 46, 47, 48, 49, 50. Again, they're not minuses, they're just dashes. And if you use your y-axis, you'll be able to work out the percentage of each. So the first one would be 46 is our mass. The percentage is 8. The next one, I've got 47 as a mass. The percentage, let's say it's just below 8 this time, so we can say it's 7. The next one, the mass is 48. The percentage this time looks there around 75. Next one is 49. The percentage there is 6. And then the last one we've got is 50 with a percentage of 4. Again, I'm putting a plus between all of these brackets. Because I'm dealing with percentages, I'm dividing everything by 100, okay? And again, find titanium on your periodic table. It should have a mass, your answer should come out as being roughly 48 point something, okay? If you have all the masses, 46, 47, 48, 49, 50, you should be getting a mass in the 40s. If you're not, then again, you've made a mistake, so go back and check your work. That's the only calculation that comes up in these chapters. The rest is a little bit more straightforward. So how does the electron configuration of an atom of potassium relate to its position on the periodic table? Electron configuration just refers to how the electrons are arranged. So potassium is 19 electrons. I can find that out by looking at the periodic table. It's got an atomic number of 19. You put 2 electrons in the first shell, 8 in the second shell, 8 in the third shell, and there's 1 electron left. That's the electronic configuration. How does the electronic configuration relate to its position in the periodic table? Well, in the periodic table, potassium is found in group 1. If I use the electronic configuration, I can see that there is 1 electron in the outer shell. So I'm going to write that the group is equal to the number of electrons in the outer shell. If I look at the periodic table as well, the other thing I'll see is potassium is in period 4. So period are the rows that go across. You've got 1, 2, 3, 4. Potassium is found here. And if I look at the electron configuration, where can I get 4 from? Well, if you count the number of shells, 1, 2, 3, 4, you'll see that that matches the period that potassium is in. So I'm going to write period equals the number of electron shells. So number of electrons in the outer shell is the group, number of electron shells in total that are needed is the period. The next question, explain in terms of subatomic particles what is meant by the term isotopes. This is a definition that you're going to have to learn. Isotopes have the same number of protons, but they have got a different number of neutrons. And because they've got a different number of neutrons, you'll see here that they have a different mass, okay? But in terms of subatomic particles, the subatomic particles are just protons, electrons, and neutrons. So you can say isotopes have the same number of protons, they have a different number of neutrons. You've got element E here, and it says all atoms of element E in the sample contain. So it says element E has an atomic number of 5. The atomic number tells you the number of protons. And if they all have an atomic number of 5. They must all have 5 protons. It tells you that the mass number of one is 10 and the mass number of the other is 11. Okay, so if I did this out, one of them would have the number 10 next to it, and one of them would have the number 11. And if I do P, E, and N, 5 protons, 5 electrons, and in this case, 10 minus 5 is 5 neutrons. Over here, I've got 5 protons, 5 electrons, but this time it's 11 minus 5 is 6 neutrons, all right? So you can see here that they both have 5 protons, that's correct. They don't both have 5 neutrons, they both don't have 6 protons, they both don't have 6 neutrons. The answer must be A. And the next one, which row shows the number of protons and neutrons? All right, so atomic number is the number of protons, so I'm looking for A or C because they have 20 protons, which matches the atomic number. It has a mass number of 40. To work out the number of neutrons is 40 minus 20. So the big number minus the small number. So I need 20 neutrons. So my answer there must be A, 20 protons, 20 neutrons. The next one, using this, which period is calcium in? So we saw already that the period always matches the number of electron shells. And you can see that we've had to draw 4 shells to fit in all of calcium's electrons. Therefore, calcium must be in period 4. So you'll write period 4 because there are 4 electron shells. The next one, John Dalton. So John Dalton was a scientist. He was the first one to kind of propose atomic structure. He believed that elements were made of atoms. That is true. He believed that atoms were not formed of anything smaller, so you couldn't break an atom down. And he believed that atoms of the same element were identical. And it wants 2 things that are different today. So which 2 things are wrong? Well, the easiest one to talk about is he thought atoms couldn't be formed of anything smaller, that you couldn't break them down. But we now know that atoms are made up of protons, neutrons, and electrons. And if you just write that, they actually count that as 2 different differences. Protons, neutrons, and electrons would actually count as 3 separate marks. So atoms can be broken down into protons, neutrons, and electrons. The other thing you can argue with is he said all atoms of the same element are identical. We now know that's not true. We know that isotopes exist, and some atoms of the same element can have a different number of neutrons. And they are all the questions.